Alina, say, you do? No, I'm not. I have a problem with this question. I need to solve this question. For question 1, I need to solve by using zero operand. And the question 2, I need to solve using one operand, but I don't know how. I think I can help you. Let's try it. Before we start with calculation, let's understand the zero address concept first. Firstly, you need to know that a zero address instruction uses a stack to store operand. To perform an operation, you must take the top two values from the stack. Remember that the top value of the stack is always the right operand, while the second value from the top is the left operand. Every operation follows this rule. For a zero operand operation, the first step is to determine the order of the register A, B, C, D. Next, determine the order of the operator based on the expiration. For this question, the first step is to determine the order of the register. The first order is A, and the second order is also A. The third order is B. Then the order continues with A, C, A again, and finally D. Let's determine the order of the operation. First, multiply AA. Second, multiply AC. Third, add B to the result of AC, giving B plus A multiple C. Fourth, subtract B plus AC from A multiple A, giving A multiple A minus B plus AC. Fifth, multiple AD. Finally, divide the first result by A multiple C, A multiple D. After determining the order of the register and the operator, we can start writing the zero address instruction. First, push A. Next, push A again. Then perform bound. After that, push B, push A, and push C. Then perform bound. Why does the multiplication use only A and C? As I mentioned before, in a zero address instruction, the operation always uses the top two values on the stack. Since C on the top and A is the second from the top, the operation is A multiple C. Next, perform add. This adds B to the result of A multiple C because the top two values on the stack are now B and A multiple C. Then perform sum. We subtract B plus A multiple C from A multiple A. After that, push A and push D, then perform bound. Finally, perform diff to get the final result, and don't forget to the last step, pop Y to store the final answer in register Y.
You will get the final result for zero address like this.
Nina, you ready to answer the next question?
Yes.
Let's go.
A one address instruction has a special register called the accumulator. It works using the one room concept where all arithmetic and logical operations are performed in the accumulator. After each operation, the result is stored back in the accumulator. The data in memory, such as location X, Y, or Z, is loaded into the accumulator whenever needed. At the end of all the operations, you should store the final value in the register or memory location specified in the question.
For a one address instruction, The first step is to draw a table like this. It makes it much easier to solve the question step by step. My table is a little messy, but it's okay. Next, determine the group of the operator based on the expression. This helps you know which operation should be performed first and writing the first address instruction. For this question, we first determine the group of the operator. The first group is B mod C. The second group is D plus 5. And the third group is 2D D plus 5. The fourth group is A minus B multiple C. Finally, the fifth group is A minus B multiple C plus 2D D plus 5. After grouping the operation, let's start with the first address instruction. First, load B, then perform mod C. After that, store at S. Why do I store it in S? It's just my choice. You can also store it in Y or Z. It's up to you actually. Just make sure you choose one temporary memory location and use it consistently. Also, make sure that memory location is not being used by any other group of operation. Next, we move to the second group. First, load D, then perform at 5. After that, store at Y. You can choose either Y or Z because as we already used, so move on from your S, my friend. It's time for a new chapter, Y or Z. Next, we move to the third group. First, load 2, then div Y, because we store D plus 5 in Y in the previous step. After that, store Y again. I'm storing the new result in Y because the previous value is not longer needed, so we can reuse the same memory location. Next, we move to the fourth group, which is A minus B multiple C. The steps are similar to the previous group. First, load A, then perform sub S because we store B multiple C in S early. After that, continue with add Y because 2D D plus 5 was stored in Y. Last but not least, store Z because the question asks us to store the final answer in register Z.
This is the final result for one address. I hope you understand it. So Lina, you still confusing with the question?
No, thank you to you for helping me.
No. Actually, you are helping me with my video assignment. Thank you so much. So that's all from me in this video assignment. Thank you for watching.